Alrighty. Well, I might get started. Not sure how many people were going to be here. I'm actually surprised there's this many people. It's quite a niche talk, but if you are doing infrastructure stuff, you definitely need it. Who am I? Mostly an idiot, but I have been doing sort of stuff around games and networked applications for a couple decades now, so I've done it wrong lots of times. But had a previous career as a web developer, and then started a studio in 2007, Digital Confectioners, which has been going pretty well. So we've done game infrastructure for a few of our titles. The first big title that we got to release was Depth in 2014, and we did a lot of back-end infrastructure for that. Started with matchmaking and dedicated game servers. It's an Unreal-based game. And then over the years, I mean, we're still supporting it now. We did gameplay metrics, quests, events, Steam inventory, Steam Workshop, a whole bunch of stuff, all of which has back-end infrastructure to run it. And all that's still running today. For Last Tide, we did matchmaking, game servers again, and currency systems. But through all of this period prior to Dread Hunger, the peak CCUs we'd ever seen was a Steam free weekend that we did for Depth, I think about 2016, and the peak CCUs got up to about 10,000, 11,000 players. I say players because servers were going down constantly all the time, everything was burning, I'm not sure how much playing they were doing. I think the most that we ever gracefully handled was about 4,000 or 5,000 concurrent players. Our systems could handle that. But we have now been using AWS for over 10 years. So coming into Dread Hunger, we re-architected a lot of things. We used it as an opportunity to rebuild somewhat. It had been a long time. Last Tide had used some of the same code base as Depth, and in that time everything had changed, from the hardware, the Linux kernels, like the programming languages, the modules, absolutely everything. So how do we use AWS? We use a lot of EC2, all the EC2. Give me all the CPUs, all of them. But we use Elastic Beanstalk a lot for running our applications. It's just a really easy way to manage scaling your applications and updating them and everything. All sorts of databases. We used to use mainly SQL, but these days mostly no SQL, and a bit of graph databases. And CloudWatch for monitoring, and the usual things like S3 and Route 53 and that. We do use Global Accelerator a fair bit. In other industries, they use a lot of CloudFront, particularly for caching and security. But for games, we actually wind up using Global Accelerator more because it can do UDP traffic and it changes how HTTPS is terminated, which for us was helpful. And WAF and Shield products, so firewalls, DDoS protection, that sort of stuff. So as a player, when you think about the back-end infrastructure, you think, hey, I've got my Unreal client, I'm playing the game on my PC, and I connect through to a game server, which is also an instance of Unreal running on some machine somewhere. But there's a few layers in between, and some people's stacks may have even more layers than this. But for Dread Hunger, we had a front-end API. This is what people log into. This is how they say, we need a match, find us a game, and make sure I'm not banned, and all that sort of stuff. And then we have a pool manager layer, which is managing servers within each region around the world. So like, say, the Tokyo servers, have we got enough machines running there? Do we need to ramp up, ramp down? And which machines have available slots on them? And then the server spawner layer, which is generally either a physical machine or a VPS, and that's running a whole bunch of Unreal instances. So for Dread Hunger, a single server spawner will run about 50, if it's a big machine, 50 or 60 instances of Unreal on it. And then the pool manager will be managing however many dozens or hundreds of servers you need in a region, and then the conductor is managing all your regions around the world. So Dread Hunger, we soft launched. We didn't do any PR or marketing as we went into early access. We're pretty quiet about it. And we're actually really happy with these player numbers. This was good. Getting up to 600 concurrent players without any promotion, pretty good. We were really happy with this. And the team were working really hard on the game. They made a lot of changes, excellent changes. And the servers handled all this stuff fine. I had deliberately designed things so that I knew it would handle 10,000 concurrent players. We thought, maybe there's a chance we get up to that sort of number, particularly if we do a big promotion on launch or something. Maybe we get thousands of concurrent players. Maybe we even get towards free weekend numbers, but we didn't actually think it was going to happen. But then this is before launch. So we got to the end of the early access period and numbers started going up. We noticed a few people playing it in Taiwan, and about a week later in China, and then it was like a few more people, and then a lot more people, and we get up to about 5,000 concurrent players on release day. And again, we haven't done any marketing or promotion yet. This is just all organic growth. But this was fine. I was feeling confident. I had built things to handle 10,000 concurrent players. What could go wrong? The numbers kept going up. A lot happened in this very small period of time. So this is only 2.5 months, but we were building the railroad tracks in front of the train the whole way through this 2 or 3 months. And this is sort of an average growth rate of about 10% a day, which, if you say it like that, it doesn't sound like a lot, but that means you've got twice as many players every week as you had the previous week, and, well, at the end of this period, you've got 1,000 times as many players as you had at the start. So if you have a server and it doesn't scale horizontally and it's at 50% CPU, you have a week to replace that with something bigger or re-architect it. So at peak scale, which was 1 to 3 a.m., I wound up having to split shift all my sleep because I needed to be online at that time. We got up to over 100,000 concurrent players, and that meant that front-end API was handling, 3,000 requests a second. And that's not a peak number, that's an average over that 2-hour span. And that's just the legitimate traffic, not the attack traffic. And each one of those requests is hitting multiple databases, sometimes APIs, which can be very slow, like the Steam API can take 1 or 2 seconds before it comes back to you. And so all up, including the game servers, we had over 3,000 server CPU cores, all heavily loaded, probably on average over 90% use. So yeah, we use a lot of EC2. So there was over 250,000 players every day, over 4 terabytes an hour of game traffic to the servers, and terabytes of logs a day. So the logs started building up. I can only imagine what it would be like with a gigantic game with 1 million concurrents. And one big difference between game traffic and previous work I'd done in web development, you can't cache anything. In web development, they're like, oh, the website's getting really busy, we've got to put a caching layer in it. You can't cache anything in games. All the traffic is dynamic. It's all custom and it's all on demand, so caching gets you nowhere. And to make it even worse, most of your database access is write access, not read access. So for us, it's like 80–90% is write. And of course, if you look up any guide on how to scale your databases, the first thing they'll say is add a bunch of read replicas. Doesn't help you in games. So there are a bunch of challenges with the scale. Scaling the infrastructure systems, so that's your APIs, how do they grow as they handle more load? Scaling your databases, that gets gnarly. The entire way through that period, we had less than 2 hours downtime, but that less than 2 hours was all for upgrading databases. Getting enough server hardware can actually be a trick. So for Dread Hunger, we really needed about 1.5 gigahertz of a modern Xeon or AMD EPYC core to run the game, an instance of the game well. 1.4 gigahertz at a pinch. But this means if somebody offers you a Xeon core that's 3 gigahertz, cool, I can get 2 instances per core. And if they offer you one that's 2.6 gigahertz and it's like 20% cheaper, it's like, no, that's useless to me. I get 1 instance per core. It's half as valuable to me. So it's not just getting servers, it's getting the right servers. And there are a lot of other non-infrastructure problems going on at the same time. So ramping customer support and community management. The team did amazingly there. There were a lot of really big challenges there, particularly given that it's all multilingual, a very global audience. So in the end, a small minority of the player base actually speaks English, which is tough when your team only speaks English for the most part. And then, as if scale challenges aren't enough, some people are assholes. So there are security challenges. We had a lot of DDoS attacks, a huge number. At peak, we were 3.4% of all the AWS Shield events across Amazon, like in the world, which is quite a lot. And I had a lot of people asking me what the hell we did. And I'm like, bro, we make games. And they're like, yeah, but like... no, what do you really do? It's like, no, seriously, we just make games. And all we want to do is have people play the game. I don't know. We got a lot of attacks. So hundreds of DDoS waves a day, 100 gigabit waves were quite common. The worst day had over 1,000 DDoS waves. You just lose track of them all. It's all a blur. Fun fact, when Putin rolled tanks into Ukraine, Sberbank, the largest Russian bank, was complaining about the size of the DDoS attacks they were getting, because, you know, you invade Europe, you get some DDoS attacks. It was only twice the size of what we were dealing with, so I don't know what they were complaining about. Doxing, yeah, if you're going to make a competitive multiplayer game, don't put your staff details on your website. I know you're proud of your staff, but don't put your staff details on your website. And the anti-cheat arms race. That's another tough one, which can be a bit surprising for people. People are paying more for the cheats than they are for your games. So typical cheats are 20 to 50 USD per month as a subscription. And that means that the companies making the cheats have hundreds of employees. They're quite well resourced and they're very good at making the cheats. So that's tricky. So with all that said, you're probably like, well, clearly we're doomed. There's no way to beat all of that. But I don't have any silver bullets, but there are actually a lot of solutions for all of these problems. You are going to need to be prepared to adapt fast. Unfortunately, experience really counts here. The fact that I had so much experience prior and had made infrastructure for games a few times before really helped. Set up a network of people who have some experience. It can help you at the time. Technical details, how fast can you test, build, and deploy, all that stuff, like having automated testing, a CI/CD pipeline that worked fast, and staging and development environments was really, really helpful. I think our test, build, deploy pipeline, maybe 10 minutes. It was fast enough that we could like move very, very quickly, and that got tested, that got needed several times. And do you know what your next scaling problem is going to be? So have you got monitoring in place such that you know, okay, that thing's going to fall over if we keep growing in 2 weeks' time, but that thing's going to fall over in 2 days, so I'll work on that one first. Load testing is helpful. I didn't actually do enough of that for Dread Hunger. We'll be doing a bit more of that in future. And leaning on competent partners, which is why this is a AWS-sponsored talk. We definitely leaned on AWS. Initially, the game only had servers in North America, and based on early sales and early access, we were only selling copies in Europe and North America, really. So that's where we were expecting to add servers. And then suddenly all the Chinese players showed up, and they were playing on 300, 400 pings. And But luckily we saw it really early on, and we were able to, because AWS is the same everywhere, you can run the same configuration elsewhere, and we were able to get a Hong Kong region up. That only took me about half a day. And then, yeah, Tokyo a bit later. Took me, I think I got it down to about 3 hours to add a region. And also, yeah, AWS, great for helping with giant DDoS attacks. I can't handle a giant DDoS attack myself, but the Shield team can. Working with the community is also very helpful. For the most part, they just want to play your game and have fun, and they can be very helpful, whether that's testing a build of the code in some weird environment or whatever. Like, yeah, do work in with the community. They can be really helpful. They can even tell you about problems or issues that you might have, or for us, unique things about the way Chinese people play games. One of them is they all play through a VPN, 100%, and that complicates networking. It's also very stressful if you do hit the success point. Like, these are the good problems to have, but it is very stressful and it will take a toll on the team. So you really do need to all be supporting each other and be there for each other. But yes, these problems only exist because you did something right. As for scaling solutions, EC2 is usually helpful because they have massive capacity in regions all around the world. For databases, for Dreadhunger, we used a lot of NoSQL, and I did use graph databases, but I had to turn off a bunch of functionality because it just didn't scale. But DynamoDB, as a key example, it's like really good, and it scales up. But it scales up and it scales down. So you can get it to go massive if your game gets big, and you can get it to go cheap if your game doesn't go big. So it's actually really good both ways. VPC and IAM set up, so that's setting up your subnets and your network and your firewall rules and all that. Do that early. You do not want to be retrofitting this later on, because having to rejig all your subnets or change your rules is it's a recipe for disaster. It's quite easy to do. It doesn't actually take all that long. Just sit down and have a think about it early on. Setting up monitoring dashboards, I found CloudWatch amazingly helpful. There's a whole lot, like if you click into almost any Amazon service, there'll be a whole lot of monitoring stuff available there. You can pull all those out and put them in a CloudWatch dashboard, and then you can just have your top most likely things. So for a database, it'll probably be like response time, CPU usage, and depending upon what it is, if it's like something like DynamoDB, it'll be read and write capacity used and read and write capacity that you've got as a maximum cap. One that you'll really want to watch, particularly if you're doing dedicated game servers and the like, is your vCPU budget in each region. That one, you can't get an instantaneous upgrade. You send a request and a human being looks at it for make sure you're good for billing and all that, and that can take a few hours or even a day. So you want to be monitoring your vCPU budgets in every region you're running servers. Make sure you don't hit that and get the request in a day or two before you hit it. But yeah, most of the AWS services come with really excellent monitoring. Like, no point reinventing the wheel. Like, it's just so good. And Cost Explorer. Every so often have a dig through Cost Explorer and make sure you haven't done something dumb that's burning money, because backend infrastructure is basically directly connected to your studio's bank account. So if you do it wrong, you can bankrupt your studio. Just be aware, no pressure. AWS has a lot of solutions for security as well. On the security side, account setup. Have a think about this. You'll probably want a separate actual AWS account for each game at least, and possibly for different environments, and then who has access to that and how that works. The VPC and networking setup, so your firewall rules, like if you're running Linux machines most likely, okay, they're probably open on 22 for SSH, but maybe that only needs to be open for your studio's IP address. or something like that. Just locking things down really, and setting that up early, then you just don't have the issues because no one can go around and find all the ports to poke. AWS Shield. So the default version of this comes with any server you run on AWS, and the default AWS Shield will filter out a whole lot of SYN floods and other nonsense like that. But there is AWS Shield Advanced, which we wound up using a lot, which will help you with more advanced detection and response to DDoS attacks. CloudFront and Global Accelerator, they are good. They can add to your traffic costs, so you've got to be careful when and how you use them, but they can be really good because they spread you out to the edge, and that means if someone is hitting you with a DDoS attack, well, they can't hit all of the edge nodes all around the world. So maybe they can deny a bit of an area, but they can't deny your whole system. It also means you can hide your IP addresses, because you do not want people to figure out what the node IP addresses are for your infrastructure. It's a bit of a Matryoshka doll shell game thing, hiding your infrastructure. But yeah, using something like Global Accelerator around your APIs just hides all the IP addresses. No one will find them. We had people just directly attacking and taking down scaling nodes around Elastic Beanstalk and stuff. It was nuts. And yes, again, setting up monitoring dashboards, it helps with security as well, because you can see when attacks are coming in, if they make it through your firewall rules and the like. I won't end it there. I've blitzed through it very fast, but I figured you may have questions because this is an area that is very case specific. So yes.
Just from that last slide, immediately, do you have these security systems in place prior to the big scaling of launch, or these things that you kind of not retroactively, but like the development of, during the spike, did you do all this?
Did we have these in place? No. Some of them. I had set up separate AWS accounts, and I've been very careful with the firewall setup for everything. Some of it I kind of got for free because most of our APIs were run on Elastic Beanstalk. That actually hides the node IPs behind a front-end load balancer. But we were not using AWS Shield Advanced. We added that on as we started getting attacked a lot. And we were not using Global Accelerator or CloudFront to start with, and we added that on as well.
Just a follow-up question. When did the attack start? During the peak, when did you start?
No, the whole way to the peak, very few attacks. It was only after the peak, about a month later actually, where they started in earnest. Yeah. I mean, there might have been the occasional one, but if it's like 10 megabit of traffic, you don't even notice. But yeah, the big ones just came in a huge wave of nonsense.
Did you identify where they came from?
Did we identify where they came from? No. Actually, on that front, I should shout out, if you are in that position, I mentioned briefly working with the community and supporting each other, do reach out to other people in the industry as well. Everyone hates the black hats, and everyone wants to knock them back a peg. And I was very lucky to get some help from the Demonware guys were great. They do Activision's infrastructure. There was a guy from Riot, Dean at RocketWorks. There are a number of people I reached out to and was able to get some advice from, and they were very helpful. But in talking from them, they mentioned that attacks used to be signaled. People would take credit for it and say, hey, we've done this, yada, yada. That doesn't happen anymore. You just get attacked. You'll never find out who. You'll never find out why. It just happens. And that's the same with COD as it is for us. We have never found out. We have absolutely no idea who or why. Yeah.
Left side of the room represent. Sorry, right side of the room represent. Anyway, you talked a little bit about doxing earlier.
Yes.
Is there a story there? And
boy.
What about like LinkedIn? Do you guys have your names associated with your company on LinkedIn?
Yeah, we didn't. Doxing is going to be the biggest issue for the people who are directly talking to customers, particularly community moderation and that side of things. They bear the worst of it. And and probably woman, to be honest. I have to have my name public because I'm a director of the company and you can look me up and that's the law. But for most people within the company, we had things like photos and names on the website, and that was a bad idea. I don't think you necessarily have to go to the degree of hiding your LinkedIn profile. It's more just when you're working, say on Discord or somewhere, you might have a nickname. You might want that nickname disassociated from your real name. If your company has a whole bunch of names, they're not necessarily going to dox it, but if they can figure out that the community manager is that person, they're going to hunt down that person and attack that person. So yeah, depends what you're doing somewhat, but yeah, I'd be careful about putting details up.
Hi. So you mentioned.
So you mentioned that you do a bit of automated testing, both on the performance testing side and the functional testing. What are some examples of those? And I also have a second question that I'm going to quickly sneak in. Was 10 years ago, was Azure ever on the table when you were looking at backend?
10 years ago, there wasn't much other than AWS. They had a massive lead on everyone else. I think Azure existed at the time, but it was tiny. Google Cloud didn't exist. In my previous career as a web developer, I'd done a lot of the manual stuff, actual sysadmin and bare metal and running things manually, and DevOps wasn't like a scripted approach wasn't really a thing. But it certainly is now, and the productivity you get from doing things through AWS is just orders of magnitude higher than the old way. So yeah, we moved on to AWS pretty early. And sorry, your other question? Automated testing tools. It's very programming language dependent. So if you're in Python, I mean, to be honest, if you're in Python, you can just use PyTest. If you're making JavaScript or TypeScript code, you could just use npm's test runner. Like, it doesn't have to be fancy. It really does. It doesn't matter. It's the approach of doing automated testing, and the fact that you can run your tests to make sure you don't have regressions and run them fast and then get that build. Like, your build system can be janky and weird, or it could be very simple. It doesn't matter. What matters is that you're doing those things and getting them fast, and so you can reliably build software.
Is that more in the unit level, or do you do some stuff at the UI level as well?
For testing, well, I'm only I did do the localization for the game as well, but I didn't really work on the game at all outside of that. But for the infrastructure, it's kind of a mix of everything: functional testing, unit testing, end to end, the whole lot. It just made it far more reliable for me to get features out, because I was shipping my stuff to be forward and backwards compatible, so that way I could just be constantly deploying new versions. Like, some days I might have deployed 10 or more times various amounts of software, and it meant I could deploy disconnected from the dev team working on the game. So I could keep working on features and just ship them, and then eventually they could build the code to integrate with those and work with them. But I'm able to move very fast and swap from one feature to another if something comes up. Yeah.
Just curious if you're deploying your infrastructure using an infrastructure as code, something like Terraform or CloudFormation or something along those lines, or is it more manual and programmatic with CDK?
No. That would be a step that could make sense, particularly if you had a larger team. Our entire infrastructure team was half of me, so it's like not a very big team. But we were able to get the deployment process down fast enough without those tools, so I didn't bother.
So with your cloud architecture design, how did that impact the actual development of the game? You know, at what stages were you speaking with your, I guess, Unreal engineers about what considerations they might be having to make from their design principles, or, you know, how that integrates with the actual game development? Did you have this, you know, layered structure in place during pre-production, during production?
Yes.
Yeah.
It is a similar architecture to what we used or what we learnt from Depth and Last Tide. So because it wasn't the first time we'd done a lot of this stuff, we were able to kind of do it again. I came in, I wasn't there when in prototype. So the team was probably at least 6 months along before I started building any infrastructure for them. But we wanted to get playtesting through a dedicated server because a bunch of the team was outside of New Zealand as well. We wanted to get playtesting within the team on reliable servers very fast. So I actually built that server spawner chunk of the software first because we just had a machine up and I ran that software on it and they could just connect manually to the IP address. And then later on I made a pool manager, and then later I made the conductor. And then we started integrating things like EOS for authentication and Steam and all this sort of stuff, and we started integrating those features into the infrastructure. And then you start building banning systems and metric systems and all that sort of stuff. So things like metrics and community management and fraud detection and all that sort of stuff, that came very late. Some of that came in early access. Yeah.
The pool manager here is really interesting. Is that also custom, and how does it know when it needs to spin up a new system? How's it tracking resources?
Yeah, it's all custom. Yes. We had looked at the service providers. There's a number of service providers online that will do game servers as a service, but they are expensive. And we can do it much cheaper, so we do it much cheaper. So yeah, this is all custom. The pool manager, effectively, it just watches how many games you actually have in a region, and then you give it some buffer allowance, and it maintains that. So we'll try and funnel players into as small a number of servers as possible, so you can ramp down servers as fast as possible, but at the same time leaving a buffer. And that buffer, you need to scale the buffer with size. So obviously if you've only got one machine, the buffer might need to be a whole nother machine. But then if you've got 50 machines, the buffer might need to be several machines. It's sort of a percentage, and it changes with the formula. But we also fire up some instances and then in AWS terminology stop them, so they're effectively hibernated. As it turns out, this used to matter a lot back with Depth, because the difference between a warm startup and a cold startup on AWS back then was like a minute or two, but now the difference is like 20 seconds, so it's actually a bit academic. I don't know if I'd even bother doing that anymore, to be honest, but technically we did have some like warm startup machines lying around in each area. Yeah.
Hey, I just wanted to ask, how much support did you have from AWS with a lot of this stuff? Like, were they recommending different things? Like you said, you've been using them for 10 years, so obviously you're familiar with a lot of their services, but were they actively trying to get you to use new services or helping with a lot of this stuff?
Yeah, it's a good question. No to the last bit. No, they weren't trying to get me to use any sort of services. How much were they involved? Early on, not really much at all, and I hadn't really reached out to them. We were just building the game, and there were a few people playing it, and everything was fine and happy and rainbows. Later on, I started reaching out to them a lot more. Please, I need some help. Oh God. And they did actually have a lot of help there. There are a lot of different ways to get help from AWS. If you are getting attacked a lot with DDoS attacks and you're using AWS Shield Advanced, they have a Shield response team, and they will literally call you up and work through the attacks and firewall rules and stuff like that 24/7, and I spent a lot of time on the phone with those guys, and they're excellent. Another way is there are units within AWS that can be used if you need extra dev help. Now, that wasn't a thing a long time ago, but in recent years that's been a thing. They've started to actually have dev resources available if you're like, oh, we need more people to help build things. And they have a huge number of training resources and just things online. One thing I found helpful, this is going back a long time before Dreadhunger, but they do sometimes run conferences, and you can go there and basically do all their courses at the conference if you're still learning about a lot of these services that they provide. That can be really helpful to get your head around things. I've kind of lost sight on what it's like to learn all this stuff now, so I can't speak too much to the I don't know how any of it works, how do I learn side very well. But there is a lot of resources out there. Yeah. Excellent. Thank you everybody for coming along. Oh, another question?
You mentioned your server's gigahertz was 1.5. How much RAM as well alongside that? I guess is the size of the map that matters.
Oh yeah.
But as well as how did you realize you needed 50 servers or 50 instances on one dedicated server? Or are you mostly doing at bare metal, running a lot of instances, or are you doing like, say, more VPSs or? Yeah.
Bare metal. So to answer your first question about RAM, not much. It depends a little bit on the technology you're using and how you optimize your game. But in general, what we find, particularly for multiplayer Unreal based games, is you don't care about RAM. You really don't. You care about CPU and only CPU and all CPU, and you just need all of the CPU. And so that's normally because you can optimize down the CPU to a certain point and then it gets hard. With RAM, you can start using instance memory sharing. So if you have a machine running 50 instances, if you've got a blob of memory that is the same for all those instances, like a map file, you can actually have one instance of that map file in memory and run it for all the threads. And so effectively, you can get your per instance memory usage down real low if you need to. It's a bunch of engineering work, but you can do it. I know Fortnite does it, and a number of other people have done it. And so at that point, memory just isn't your bottleneck at all. CPU is entirely your bottleneck for the game servers. As to how we knew how much you needed, that's actually not too hard to figure out. You just literally benchmark the game when you're play testing it, and you get a pretty good idea. And then run it on one of the servers that you're anticipating using, like fire up an EC2 instance, run an instance, and just watch it and be like, okay, it's using about whatever. So if you're in Linux, you might say, oh, load averages up to 1. Okay, it's using 1 core or something like that. Yeah, so we figured that out pretty early, and there were some optimizations done, but yeah, getting it much further below 1.4, 1.5 gigahertz per server, it started to get increasingly hard. And obviously the dev team are busy trying to do other things, like gameplay features that players care about. So things you need on the infrastructure side tend to be pretty low priority. However, they can save you a lot of money if it's badly optimized. As for bare metal versus EC2 instances, bare metal and EC2 are completely different products. Completely different. We use both, and most people at scale are probably using both, but they're completely different products. A bare metal instance is quote-unquote cheaper, generally, but you're buying it for a month, 3 months, a year at a time. Often you can't cancel it without a month or two of lead time. It doesn't have DDoS protection that's as strong as AWS offers. So there are strengths and weaknesses to it, and you can't just fire up 100 bare metal instances when you need them now. One thing that is probably unique somewhat to us was, you can't really see it in any of these graphs, but the China player base has a very strong peak and trough. Very strong. So North America and Europe, your peak and your trough are about 2-to-1 ratio difference, and China is 10-to-1. So they all show up and then they all disappear. And so that means you are like bare metal it's not going to be what gets you through if you're dealing with a Chinese audience. But maybe you can use it for a North American or European audience more. I don't know. Yeah, we did use both, but another one of the problems with bare metal is finding the hardware. So there were a lot of people with Xeon processors that were like 2.2 gigahertz, but I could only get one instance per core on those, and so they wound up being quite expensive. And so what wound up being best for us was the AMD EPIC processors, because I could get 2.8 to 3 gigahertz cores. But even then it was a struggle. Like bare metal providers would be like, oh yeah, we've got a few of those in Singapore, we can ship them up here, they'll be there in a week. It's like, oh, a week? Well, I'll be twice the size in a week. So yeah, we use the mix of both, and you're probably gonna want to use a mix of both. Yeah, they just have different strengths and weaknesses.
In terms of the peaks and troughs you mentioned, were you aware of that going into development, about the cultural? Yeah, that's what I was just curious about. How did you react to that? Did you just find out through experience over time, or did you just figure it out very quickly in the moment?
Yeah, so previously our games had sold principally in North America and Europe, and particularly actually in Eastern Europe. One of our biggest sales regions was Russia, and that included for Dread Hunger. So early access, during the early access period, the whole way through here, our number one sales country was the United States, and our number two was Russia. And obviously that disappeared the day after the Swift block went in. But we noticed it because in the Chinese regions, like, yeah, the servers just had to ramp super hard at about midnight, 1 a.m. and then just they all disappeared by 4 a.m., 5 a.m. It was like, yeah. And also China has a double peak. So it has a small little peak in their afternoon come evening, and then it has a later evening peak, which is much bigger. They have a very distinct, there's different shapes for your player base depending upon where they are in the world. It's less obvious in something like Steam charts if you're looking at a game, because you're aggregating all of the regions at once. But if you find a game that is particularly used in one region or another, you'll notice that there's a few games out there and you can tell they're a China audience just by the shape of their daily peaks. Yeah, it's there was a lot to learn. I was very happy with how everything went. I was comfortable that what we did would have handled 200,000. If I was lucky, maybe 250,000. If we got into 300,000, I don't think it would have been possible though. With the systems that I had built, I would have had to fully re-engineer a whole lot of stuff, and I wouldn't have had the time. So I'm glad I didn't have to deal with that. There are options, but it's pretty tough because rebuilding all those systems on the fly while things are growing is, yeah, that's not going to be a good experience.
How did you go about scaling the database?
Scaling the database, yeah.
Yeah, we ran into that issue, and yeah, it fell over multiple times. And
so I mostly used two databases, Dynamo and Neptune. Dynamo's, that's just like change the number for maximum read and write usage. Cool, I've done my scaling, job done, go home. So that was really nice. Like Dynamo just scales real hard. I don't know where the upper limit of Dynamo is, but it'll be some stupid number. the Neptune stuff was tricky. So previously I had more experience with SQL databases, but I was doing some fraud detection work, and so a graph database was a better fit for finding out who's related to who, to do with anti-cheat and a few other things. But that did not scale very well. Even being very careful about indexes and exactly how I access things and how often I access them, it just did not scale very well. So all of our downtime was me upgrading the Neptune database, and each time it was just, can I have an instance 4 times bigger? And then like a month later, nope, can I have an instance 4 times bigger? I forget what size instance we had at the end, but it was some gigantic thing. And it's since we've been able to scale it back down again. Scaling your SQL or graph databases is just really specific to your queries. The obvious thing is make sure your indexes are actually working. You might get a 10x just from putting an index in. I've seen that before. I've done that before. But yeah, probably the leading indicator for the databases was CPU time on the graph databases, just watching that CPU time. And it doesn't scale linearly either. So if you're at 50% CPU, you're not going to get twice as many people on before it goes down. You're going to get like 1.6 times or something. Yeah, nothing scales linearly, unfortunately. So luckily we'd put a lot of our stuff on DynamoDB and just put them on NoSQL tables. I actually felt a bit uncomfortable going into it, how much we'd put into NoSQL, but in hindsight it was absolutely the right decision. The reason I was uncomfortable was it meant it was difficult to do aggregated queries for metrics purposes later on, and I didn't get round to doing a data lake and sucking things out that way. But in hindsight, I didn't have time to do all those aggregated queries anyway, and I really needed the scalability, so that was more important.
You mentioned quite early on that third-party APIs that you were tending to back onto could have some latency in them themselves.
Oh boy, do they.
Steam? Sorry?
Yes.
Yeah. Did you notice any difference in latency as you grew, like with them, or they were just solid?
So we used a number of third-party APIs. It depends which ones you're talking about. If you're talking about something like PlayStation, Xbox, Steam, they deal with games that have millions of concurrents, so you're not going to make any difference to them. They won't even notice you, even as your game's huge. It's amazing. But they are slow. They are just always slow. Like, you never get a response from the Steam API within a second. Like, you just don't. Luckily, you don't get responses from them more than 2 seconds. It's normally about 1 to 2 seconds for the Steam API. But it does mean that, for instance, all our code had to be fully async. Like, you can't have any threads waiting on a response. And you really want to minimize how often you're hitting those APIs, because it means that your API can't respond within 1 or 2 seconds. Our API probably had an average response time of about 100 milliseconds or something like that, which was pretty good, but that average would have been severely curtailed by the calls that required checking Steam for whether they're VAC banned or whatever it is. Yeah, so async is good. Do async. Yes. Cool, I think that's about all the time we've got, but happy to answer any questions afterwards if you've got more. Thanks for coming along, everyone.